Hi everybody, today I will present the paper Image Super Resolution via Deep Recursive Residual Network. This paper is accepted in CVPR 2017. First, I will explain the super resolution problem. Super resolution is a technique to enhance the resolution for images and videos. For example, we have a super resolution problem algorithm. It will take the low resolution as the input and generate the high resolution one. It is an ill-posed problem because there are many ways to generate new pixels. The author proposed the DRRN method, which stands for Deep Recursive Residual Network. The main idea of this method is, first one, the network is deeper, so it can learn the feature map better. The second one is a residual connection. It will have better gradient flow. And finally, they have recursive blocks. It will reduce the amount of parameters by weight sharing. By this architecture, it can achieve the highest PSNR while the number of parameter is still low. This is the architecture of DRRN and the previous model. We can see that the DRRN model is inspired by the previous one. This is the overall architecture of DRRN, and this is very similar to VDSR. But instead of using the convolutional layer, it uses a recursive block. And if we zoom in the recursive block, we have this structure. Inside this structure, it uses skip connection and residual unit. It is similar to the ResNet structure. It's similar to ResNet structure. And the DRN use the recursive structure. This recursive structure, it is similar to recursive structure in DRNN. So the DRNN, the proposed method, is an extension of the previous one. This is the experiment result of the proposed method, and with the different setting of number of recursive block and number of residual unit. For example, this architecture, we have six recursive block and 3 residual unit. As you can see that when we increase the residual unit, we have higher PSNR, and when we increase the number of recursive block, we also have higher PSNR. So the deeper the better in super resolution is still true. This is the comparison in PSNR and SSIM among the method. The dataset is used is this one. It is very famous in very well known in super resolution. The scale factor is set to 2, 3, and 4. We can see that the proposed method outperforms the existing method in both PSNR and SSIM in all the dataset. It is the visualization of the proposed method and the other one. We can see that the proposed method has very high detail, rich texture, compared to the other method, and it is very similar to the raw truth. This is the same thing. It is very high PSNR and SSIM. Through this paper, we have some lessons learned. First one is the deeper and the better is still true in image super resolution. And second is the gradient flow control and recursive structures is very important in training deep network. But the paper have some problem that we can improve. The first one is the cost function is still very simple. It's just use the MSE loss, so we can extend the cost function, take the SSIM into account. The second is if we can take some image processing into consideration, the result might be better. Okay, thank you for your attention.